Relations and functions. So as we talked about in class today, two things that go together are relations, like peanut butter and chocolate. So in a relationship, you will have an independent variable and a dependent variable. We call these the input and the output. The input is what you choose. Like in an experiment, you choose that you want two different types of fertilizer. That's independent. Output, the dependent variable, is what you find, which will be y. So for example, in an experiment, the dependent variable, what you find, is different heights of plants. So that is what you find, and it depends on the type of fertilizer, what you chose. So your input and your output. A relation pairs a set of inputs with a set of outputs. So it pairs x with y. There's different ways we can map these to look at them. Again, we did this in class, so we could say A, B, and C, 1, 2, and 3. Each of these pairs to one of those. One to many might say that we have A and B, 1, 2, and 3. A might pair to a couple of them, whereas B only pairs to one. Many to one. Well, we have many inputs, so we have A, B, and C, but we have less outputs, so maybe just 1 and 2. So A and B might pair to these, but C also goes with 2. And then in many to many, if we have A, B, and C, 1, 2, and 3, well, A might pair to 1 and 2. B might also pair to 2 and pair with 3. And then maybe C pairs with 2. So you can see that there are many here and many there. They both are popular, so to say. So then the example we did, we found that out of the test scores of Harry, John, Carla, Mark, and Sylvia, our test scores were just like so. And two people actually got the test score of 60, John and Carla, whereas the rest of the test scores were only received by one person. So over here we have many, over here just one. So this is a many to one. Go ahead and try these on guided practice and check the ones if you did them in class. 1, 2, and 3. Oops. Okay, so let's understand functions. Okay, so a function is a type of relation that assigns exactly one output for each input. Okay, that means that there are more x's than y's, or they are equal, because remember, y cannot. Why not? Y cannot be the many. So some examples in real life: if you're pressing numbers on or if you're pressing letters on a keyboard, well, there's only going to be one output. So if you press an A, only the A is going to come out. So this would be a 1-to-1 relation, because you push one and another one comes out. Another example might be when you're buying things. Well, some things have the same price, like a bowl and a glass and a plate might all be $2. So therefore, what you put in, what you're buying, there's many of them, but there's only one price. So that would be many to one. Okay? We can draw that here. Your bowl, your plate, cup? Well, they all cost $2. So with the keyboard, you push the A, you get an A. You push the B, you get a B. 1-to-1. Alright, a third example we see is a football player in his lineup. So maybe in a football game you have tight end and wide receiver. Alright, we're going to compare this here to soccer because that is the real football. So in soccer, you might have many players, but there are not as many positions as there are for players. So, for example, we're going to come over here. For example, you have 3 players, Billy, Bob, and Joe, on a soccer team, and we need a couple defenders, and we need an offense, because if you're playing a game with only 3 people, you're going to want to make sure your defense is strong and you have a good goalie. So Billy and Bob are both going to be our defense. But we do need an offender. Joe's pretty good, so he'll be our offender. This would also be many to 1. And this is another relationship. Okay, in the Dewey Decimal System, in a library, you go and this is 1 to many, by the way. And in the system to check out books, you might see the 400 section, the 300 section. Well, in the 400 section, it might be languages. So you might get English and German. Well, in the 300 section, you would get things like maths and sciences. So probability, and zoology all might be within that section. So that would be a 1 to many relationship. Let's try an example. 2, and it says show relation is a function from a mapping diagram. So it gives us the athlete number and the height that they have cleared. So let's go ahead and look at this one. Alright, the athlete numbers are 1, 2, 3, 4, and 5. And the different heights we could possibly have are 139, 143, 145, and 151. Okay, so athlete 1 is 145, athlete 2 is 139, athlete 3 is 143, athlete 4 is 151, and athlete 5 is 151. Now it would make sense that athletes cannot have 2 different heights. Each athlete can only have 1 height. And over here, none of these go to 2 different heights. They don't split. So therefore, this, yes, is a function because no input has 2 outputs. Suppose the athlete's heights cleared by the athletes. So yeah, say we were to switch this around, like that. C is just telling us that if we were to flip it and heights were to be the input and athletes were to be the output, then no, it would not be a function. But the way we're doing it, like this, input output, this is a function. So try this in guided practice 4, 5, and 6. Okay, so we have looked a lot at graphs recently, and graphs can actually give us a really easy way to tell if something is a function. So it's called the vertical line test, and it's actually really nice, convenient thing to use. So in the vertical line test, it says that it is a function if when vertical lines are drawn, no line goes through two or more points. So basically it can only go through one point. So if we have a graph like this, and our line is coming this way, alright, I could draw a line here, draw a line here, 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 here. None of my lines that I drew went through more than one point. So this passes the vertical line test. This is a function. Now, if I were to draw one that looked like this, and when I draw vertical lines, it passes through multiple points. This one is not a function. Okay? So we just need to know that for every input, there's only one output. So for every x we put in, every time we go over, there's only one y. So because here, this x, say this was 2, it would have a y there and a y there. So you can't put in one x and get two y's out. It's just not possible for a function. It's not possible in a function. Example 3, explain whether the relation is a function from a graph. So in the graph that it shows us, and it looks similar, well, it looks like this. So if we were to draw lines through, we get to this point 165 and we see, oh, it hits 1, 2. Therefore, it is not a function because it fails vertical line test. Because remember, why not? Y cannot be 2. Try that on guided practice 7 and 8. Finally, let's try example 4. Tell whether a curved graph is a function. So we see a graph that looks like this, and you get on it a line that's curved. Okay? So this line is curved. Well, is it still a function? Let's see. Every line I do only has one point where it hits the line. There's nowhere that I drew a line where I would get 2 points. Therefore, yes, it's a function. Alright, so basically, this is how you do it. If it were to be a curved line this way, and it went that like that, then you would see that it's not a function. But you'll see that in the guided practice. So try the guided practice 9 and 10, and that's all for this video.